Let's talk about counting rules. Let's assume, just something to think about it, if you have a dozen eggs here, a carton of dozen eggs, and these eggs are fine, and there's 3 cracked eggs or 4, doesn't matter how many. So there's 1 egg that's cracked here, 1 egg that's cracked here, 1 egg that's cracked here, and we're going to reach in and pull like 4 eggs. Well, if you pull in 4 eggs, there's a chance of what? 0 cracked, 1 cracked, 2 cracked, and 3 cracked. We need to figure out how many ways can you have 1 cracked eggs, or how many ways, how many times, different options, different possibilities you can have 2 cracked eggs. When you have 12 eggs and 1 cracked, there's 12 different ways you can have 1 cracked. Or actually 9 different ways here. Because you can reach in, the first one could be cracked, second one is not, third one is not, fourth one is not, fifth one is not. Let's only select 6 of them. 6. I'm talking about just 1 cracked, or it could be the first one not cracked, the second one is cracked, not, and not. Or it could be not, yes, not, and not cracked. Not cracked, not cracked, not cracked, cracked, not cracked, not cracked. I'm already getting tired just writing N, C, N. That's only just for 1 cracked egg. Out of 6, you're selecting 6. What's the chance of 1 cracked? Well, when you look at it, just to select 1 cracked egg, well, the chance to be cracked, there are 3 cracked out of how many? 12? Not cracked, how many not cracked eggs? For the first one will be what? 9 out of what? 11? For the second one will be what? We're assuming the eggs are sitting on the side here. 8 out of what? 10? For the next one is what? 7 out of 9. For the next one is what? 6 out of 8. And for the last one is going to be what? 5 out of 7. That's just for one of these cases. Now for the last one, to reverse them, this will be 9 out of 12, 8 out of 11, 7 out of 10, 6 out of what? 9, sorry, 6 out of 9, 5 out of 8, and what's the last one? There are 3 left out of how many? 7. Well, if you look at the top numbers and the bottom numbers for each case, exactly the same. These actually for the first case is for the last case. Look at the top. You got a 9, you got a 9, 8, 8, 7, 7, 6, 6, 5, and 3. Look at the bottom, 12 through 7. So the answer to each one of them is the same. It's just the order is different. So you find the answer for one case, you go, well, I got 1, 2, 3, 4, 5, 6 cases. Let's multiply them. 6 times that number, and that's the chance of 1 cracked egg. Well, I don't want to have to list these, so I got to look for ways to give the answer to that. And we do have an equation that will give us how many different possibilities. We have 2 terms. One is called permutation, and one is called combination. But before we get to them, because they involve using the factorial, let's talk about the factorial for those people not familiar with it. The factorial symbol, I don't know why it's keep moving here, is this one. That's what we use. Exclamation point. So when you write 4 factorial, what does that mean? Mathematically, it's 4 times 3 times 2 times 1. You start with that number and you decrease till you hit the 1. That's 24. 3 factorial. 3 times 2 times 1. 6. 2 factorial. 2 times 1. 1 factorial. That's just a 1. 0 factorial. This is by definition, is a 1. Again, by definition. It doesn't fit the mold. Oh, I got 2 eyes there. Five factorial is 5 times 4 times 3 times 2 times 1. It's 120. Most of you probably have a button on your calculator that has the factorial on it. Now, if you have one of those graphing calculators, there's a button that says math on it sometimes if you see it. Where's the math button on this one? That's the 86. I don't use that often. Math, math, math. Anyone see math on this one? More, quit, alpha, insert, solver. Math, I see it. Turn on. When you click on the math, on my calculator, there's a button that says probability. On yours, you have to put the arrow to the right probably 3 times. You'll see PRB, which stands for probability. And if you click on that, you should see the factorial. You should see something called NPR and one called NCR. So if I want to do 5 factorial, I go 5 factorial, and I hit enter. It's 120. 4 factorial. 24. 0 factorial. 1. 1 factorial. 1. 2 factorial. 2. 3 factorial. 6. You can't take the factorial of a negative number. So if you write negative 1 factorial, negative 1. If you do a negative 3 factorial, this one gives you negative 6, right? I just said you can't take the factorial of a negative number. Why is the calculator giving me an answer? This is not a cheap calculator.
It's probably just taking the negative, positive.
Hey, well, no, actually, you almost had it. Because then it's not in parentheses. It's actually taking the factorial of 3, just like when you have this. Negative 3 factorial. It says, let me find the answer to this. It's not finding the factorial of a negative number. It says, let me find the answer to this, which is what? 6, and there's a negative sign in the front. If I want the negative 3 factorial, put them in parentheses and try that now, and see if you get an error. Because that says, take the factorial of actually a negative 3. Can't, yep. Error, domain. So that's why when you see that, go, what is wrong? Just like when you take, what is negative 2 squared? Now you're thinking, that's a plus 4. It's not a plus 4. That's a negative 4. Because it's not the negative 2 that's being squared. It's only the 2 being squared, and add the minus sign to that. If you want the negative 2 squared, the whole thing, that's a 4. So that's why on your calculator it said negative 3 factorial is giving you negative 6. But the truth is you can't take a factorial of a negative number. Okay, permutation. Let's talk about 2 words, permutation combinations. I have them on my calculator, NPR and NCR. And the other one's combinations. Let me talk about both of them. permutations and combinations. When do we use each one? We use the permutation when first no repeat. No repeat. And for permutation, the order counts. Here the order doesn't count. What does that mean, the order count? If we decide we're going to select a president, vice president, and secretary for the engineering club here, and the first person we're going to select is the president. So I'm selecting Adam as the president, Jamie is the vice president, and Kathy is the treasurer. That is different than if Jamie is the president, Adam is the vice president, Kathy is the treasurer. It's different than if Kathy is the president, Jamie is the vice president, and Adam is the treasurer. Each one is a different group, so the order here counts. On the other hand, if I said to you, you know what, the engineering club is meeting to discuss buying a soda machine for the lounge downstairs, or a new coffee machine. We're going to select a subcommittee to discuss the benefit, the good and the bad of having a small coffee machine there. So it's not a president, just subcommittee, a group of people are going to discuss it. So if I pick Adam first, then Jamie or Kathy, does that make a difference which name we pick in first, or which person we select first? No. These people are the same group. Nobody has power here. Nobody has more important job than the other. They all have the same level.
Like a council?
Exactly. Once you give them title like president, vice president, treasurer, then becomes the order is important. Or if I said to you another example, you know what? I got 3 tickets with me to go see Iggy in Boston. And these ticket seats are next to each other. I'm going to give them to 3 different people. The word different, I use that intentionally. What does different means here? No repeat. Same person can't get 2 tickets. No repeat. 3 different people. If I say, you know what, I'm going to give 1 to Nick. Mark, I'll give you a ticket too. Abbas, I'll give you 1 too. Since you just came from Iowa, we'll give you a ticket. So you guys are going to go in a van, sit next to each other and watch the show. You sit next to each other. So it really doesn't matter if I pick Abbas first and Nick and Mark, or Mark first, Nick, Abbas, Mark, Abbas, Nick, Abbas, Mark, Nick. It's the same 3 people going to be going there. Doesn't make a difference which one I pick first. On the other hand, if I change this to us, you know, one of those tickets is backstage. You get to meet Iggy. Get to shake hands with her, and they have food there if you like to eat. The other ticket is in the 2nd row. You know about that 3rd ticket? I really don't have a 3rd ticket for the, but they said we can park our car in the parking lot and hear the music. So in the parking lot. So you can park your car and hear the music there. So it does make a difference if I select you first, second, or third. If you're first again, you're going to go backstage, meet Iggy there, have food, drinks all night, enjoy the concert. If you're selected second, not a bad ticket. You're in 2nd row. But if you're third, big deal. You can turn the radio on here. You're not seeing anything. So it does make a difference which way, who was selected first, second, third. That becomes permutation. This is combination. So how do we use them? Usually, when you have a problem, we said we have that many people, like in this class, if I want to select 3 people to go to that concert, I go, let's see how many people we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm not going. I got things to do. Otherwise, I'll be going. I like Iggy. We have 17 students. We're going to select 3. So the way we write that, again, if the seats are next to each other, it's no big deal. We go 17 NCR3. We have 17 people. We're going to select 3 from them. Instead of NCR, a lot of times we cheat. We write that 17C3. People know NCR or C stands for combination. Now, the same group of people, if I want to pick somebody who's going to go backstage, somebody in the second row, somebody in the parking lot, this will be 17 NPR3, which is 17P3. So this is how many you're selecting. This is how many you have to choose from. So mathematically, how do we do this? If I don't have a calculator that does NCR and NPR, it's called NCR, and the NCR is really, it's n factorial divided by n minus r factorial times r factorial. And the equation for the NPR, it's n factorial over n minus r factorial. That tells you how many different possibilities, combinations exist. So let's look at that, the first one, the 17 people, we're going to select 3 people to go see the concert, sitting next to each other. 17 NCR3. This will be 17 factorial over 17 minus 3 factorial times 3 factorial. Which is what? 17 factorial over what? 14 factorial times 3 factorial. I don't have a calculator. I'm going to do it by hand. Or my calculator died. I'm taking a test. My calculator is dead. I need to do this one. What's 17 factorial? Isn't that 17 times 16 times 15 times what? Bless you. Times what?
Times 14.
14, then what? 13, 12, 10, 11. Well, wait a minute. 14, 13, 12, 11, 9, 10. Isn't that 14 factorial? So instead of listing all the numbers going crazy, go, you know what? I'm multiplying by 14 factorial after that. And I can make my life easier. There's the 14 factorial. What's 3 factorial? That's 3 times 2. Times 1. I don't need the 1. So now this cancels that. By 3, this is 1. By 3, this is 5. By 2, this is 1. By 2, this is 8. 5 times 8, 40. It's 40 times 17. There's 680 different groups of 3s I can choose to go to that concert. $680 different people. I mean groups of 3s. Now if I do the permutation, again going back to a backstage ticket, second row in the parking lot, this will be 17 factorial over 14 factorial. That's 17 times 16 times 15 times 14 factorial over 14 factorial. And you get a big number. You got 17 times 16 times the 15. $4,080 different groups I can make. Now, a lot of times you hear the word without replacement with these problems. I wonder why they say without replacement. Anyone knows why? When we talk about NPR and NCR, you hear the word without replacement mentioned with them. That goes back to this slide. Without replacement. What does that implies? No repeat. Because when you replace something, you could pick that person again. You can't use these methods if there's a repeat. So if you look at the notes, they'll say we select R of the N items without replacement to let you know there was no repeat there. Now an example where you probably use this equation is if you play Powerball, gamble. Let's look at the rules for Powerball. I forgot exactly what the rules for Powerball. Give me 1 second. Let me go on Google. How many numbers to choose from? I forgot exactly how many. I know there's the Powerball number and there's the normal one, Powerball. Powerball numbers. How to play. There we go. Where are they? It says, we draw 5 white balls out of a drum with 59 balls in it. So we get 59. By the way, if you ever played the Powerball, you get to select 5 numbers. Then there's the power number. So there is no repeat in them. There are 59 numbers to choose from, and you're going to select how many? 5. This group, you have the Powerball number of 35 numbers, and you get to select how many? 1. You got to match all these numbers and that number to win the big prize. I don't want to win a free ticket. I want 280 million. So I got to match all these 5 numbers plus that Powerball number. So if you just go and buy a quick pick ticket, what's your chance of winning? It's not going to be that high. Now again, there's a basket that spins. It has 59 different numbers, so there is no repeat. The other good news, they don't care if your number comes out like this. When they have the drawing, they go, okay, they open the chute, here's a number. Number 48 just came out. Next number is number 17 just came out. Next number 29 just came out. Number 3 just came out. And number 56 just came out. Then they go to the other drum, they spin the balls, they reach in, open a chute, there comes a ball. The winning number is number 9. So today's winning number is, they take them and they put them in order. They go 3, 17, 29, 48, 56, and the Powerball number is 9. If you get these numbers, congratulations, you just won 280 million. So the order, the way these come out, it's not important. So order is not important, and there's no repeat. Order does not count. Again, the order, the way they came out, the way these balls came out, it doesn't matter which one, first, second, third. As long as you have the numbers, and that number you win. And no repeat. So which one of them here? That looks like the NCR. So what's your chance of winning? Your chance of winning the Powerball, you get 59 numbers, and you're going to select 5. That's just for this group. And always means multiply. You get 35 numbers there, and you want to select 1. So let me get my calculator handy. First, let me tell you what they're saying on their website. Your chance of winning. If you only buy one ticket, your chance of winning, ready for this number? 1 in. This is exactly on their website. 175,223,510. That's your chance of winning if you buy one ticket. If you buy two tickets, your chance of winning 2 in that number, 2 over that number. If you buy 10 tickets, 10 over that number, unless it's the same number. So now let's see if these actually will give me that number. Let me go to my calculator here. The 59, choose 5. I'm not going to do them by hand. I'll be crazy. I'll go to math. Probability. There we go. 59. NCR. Choose 5. Hit the equal sign. And the answer to this, 5,006,386. Times, this is actually 35, the answer to this. So the second one's 35. So take this number, multiply it by 35, and see if the answer is 1 out of, or 175,223,510. So that's how that number came up. It's not like, oh, let's put that number up there. No, somebody calculated that number. You got to match this and you got to match that.
I'm trying to do it like you did on your calculator, but it won't. Like it's not coming out right. Like it doesn't look like yours. Like it's literally just NCR and then there's like a parenthesis next to it.
But then you got to put, in your case, you got to put 59, comma 5.
Oh, 59,
Comma 5.
comma 5. That's a big number.
5,006,386. Is that what you got?
Yep.
Yep, that's for this piece. And if you go NCR 35, comma 1, it should give you 35. Then you multiply the two numbers. Now going back to that egg, the cracked egg, I like that story because that's more challenging. Here we go again. A box of eggs, a dozen. And these are big eggs, like an emu eggs. I just saw one. It sells for $12 an emu egg. It's about this big.
What does it look like? Just
Black,
like
on the outside is black. They say the inside is white, but it's hard. Like if you drop it on the floor, it probably won't break. You need like sledgehammer, really hard to break. Ew. Whole Food sells that. It is disgusting. Let's say I want to select 6 eggs. Select 6. What's the chance out of the 6 I select? 2 will be cracked. And if 2 are cracked, that means 4 of them are what? Normal, not cracked. This is more challenging. When you look at that, you're selecting 6, 2 cracked. Well, how many different ways can you select 2 cracked? Well, how many cracked ones do we have? 3, right? So 3 NCR 2. You got 3 cracked, and you're going to select 2 of them. And going back to the normal one, you have how many eggs there? Normal eggs, not cracked. We have 9 of them, right? And how many you want to select now out of those 9? Well, 4 not cracked. That becomes 9C4. So you have to look at two different ways. You get basically like equivalent to having two baskets. One has 3 cracked, I'm gonna select 2. How many different ways can you select 2 from 3 cracked? Well, it could be the first and the second one cracked, you know? Could be the second one and the third one cracked. Could be the first one and the third one cracked. That's how many different ways you can select 2 cracked eggs out of 3. If you do the math, 3 NCR 2, it gives you the answer of what? 3. Because these are your option to get 2 cracked eggs out of 3. The other basket, you got to picture that, a basket with 9 eggs, and you want to select 4 of them. Well, I could select the first one, 4. It could be egg 1, egg 2, egg 3, egg 4. Or egg 1, egg 2, egg 3, egg 5. Or egg 1, egg 2, egg 3, egg 6, and so forth. So how many of them? Let's go to my calculator and see how many of these options exist. That's 9, choose 4. Nine NCR 4, 126 different ways. So 126 times the 3, that'll tell me how many different ways you can select 6 eggs, 2 cracked, 4 not cracked. There are 378 different ways we can select 6 eggs, where 2 of them will be cracked and 4 of them not cracked. A lot of combinations, a lot of possibilities. Here's another example. In the morning before I get here, I go to the gym, I do my workout, so I have one of those combination lock. And to open my lock, I gotta take that wheel, and it's numbered from 0, I think, to 59. 0, 1, 2, 3, 4, all the way. So I gotta spin it to the left and stop at one number, then go to the right, pass that number, come back to it and stop, then go to the left. So I gotta match 3 numbers to open that lock there. And if you can make your own combination, how many different 3-digit combinations can you make? Now, I'm not sure can you repeat on these locks? You can?
I've had locks like that. You can repeat.
You can repeat. So since you can repeat,
It's like a weird, like you can do like a number and then you have to do like one full rotation.
and come back to it again.
Back to it.
Yep. So since you can repeat, yes, you can use 10, 10, and 10 if you want to open that. Which one is that, NCR or NPR?
Neither, because they're both no repeat.
Correct, neither. You can't. Why? Because you can repeat the number. So then how many different ways can you actually make a combination there? Well, for the first digit, when you're sitting there in your house there on the kitchen table thinking, what number should I use? How many choices do you have to choose from?
60.
60. And for the second number, how many choices? 60. And for the third one? 60. So this one neither NCR nor NPR, because you can repeat. So it would be 60 times 60 times 63 times. And there's 216,000 different combinations. So if somebody gonna come in and really open my locker and go, you know what, on my first try it worked, they're lying, or they're the luckiest people. Because there's that many different combinations that exist. How come they open so quick? Because they've been watching you. You know?
But they have really good hearing.
Some people actually they can feel it as you move it. Like there's this, like you can feel it where if there's a hole there. I tried that. No, I didn't feel anything. So in this case, it's neither one. pizza shop. Let's say we walk into East Longmeadow Pizza. Very good pizza. Pizza shop. And you want to get a combination pizza. And the sign says select 4 different items from a list of 12 items. That's how your combination. Select 4 different items from a list of 12. They have peppers, mushroom, tomatoes, eggplant, pepperoni, hamburger meat, sausages, onions, all the stuff on it. But you can't repeat. I made the word different. So you can't say, you know what, 4 different plants. I really like pepperoni. Put pepperoni. And for option 2, put pepperoni. And for my third one, put more pepperoni. For my fourth one, put extra pepperoni. They're going to say no. Has to be 4 different. So how many different pizzas can you make? Combination pizza. Now the question becomes, if they put the pepperoni first and the hamburger second, is that pizza going to taste different if they put the hamburger first, pepperoni second? So the order we put them on that pizza, when we're making that pizza, which one, if we put the onions first, then I decide, you know what, I like eggplant, put some eggplant, and I like green peppers, put some green peppers on them. It's going to taste the same if I reverse the order of them. So order is not important, and no repeat. That sounds like a combinational problem. I have 12 items, and we're going to select 4. How many different pizzas? Let's go in maths. You can go almost a year and a half, eat pizza every day for lunch without eating the same pizza again. There's 495 different pizzas they can make. Divided by 365 days in a year, you can go 1.356 years. A year and a third of a year, a year and 3 months, 4 months. That's more than 4 months, probably a year and 5 months having pizza every day and not repeating the same pizza once with these 12 items. Okay, I think that